Which rocket engine is generating the most buzz right now? For many, the answer is likely Starship's Raptor 3, the most advanced and powerful version to date. But did you know that this isn't the ultimate goal for SpaceX? Enter the Raptor 4, a supercharged evolution of the engine that's already redefining what's possible in space exploration. With groundbreaking upgrades and immense power, this new version is shaping up to be worth the wait. But just how powerful will the Raptor 4 be? Let's dive into the details on today's episode of Great SpaceX. Starship is rapidly evolving, with the V2 version set to debut soon, and the even more advanced Starship V3 already on the horizon. Each iteration brings significant upgrades across every system, but none are more transformative than those applied to its engines. In the initial V1 versions of Starship, the Raptor 2 engine was the powerhouse of choice. With an impressive 230 tons of thrust at sea level and 258 tons in a vacuum, Raptor 2 propelled Starship to a liftoff thrust exceeding 7,000 tons. Twice the strength of the legendary Saturn V, which was powered by the iconic F1 engine. However, change is coming. Starting early next year, Starship will transition to the V2 prototype, which is expected to initially use Raptor 2, but the real excitement lies in the arrival of Raptor 3. Elon Musk has confirmed that this upgraded engine will make its debut next year, likely alongside the V2 upgrade for the Super Heavy booster. Raptor 3 was first introduced in 2023, demonstrating a thrust of 269 tons during testing. By this year, it had surpassed expectations, with its sea-level thrust climbing to 280 tons and vacuum thrust reaching an astounding 306 tons. This upgrade will elevate Starship's overall thrust to over 9,200 tons, and Musk isn't stopping there. He has hinted that SpaceX aims to push Raptor 3 to an incredible 300 tons of thrust, potentially bringing Starship's total liftoff power to an astonishing 9,900 tons. Exciting, isn't it? But wait, that's just the appetizer. Enter the star of the show, Raptor 4. During a presentation in early 2024, Musk teased the development of a Raptor engine capable of reaching 330 tons of thrust. He later emphasized this vision during a visit from Tim Dodd and the Everyday Astronaut team. With such power, the future Starship could break the monumental 10,000-ton thrust barrier, making it 3 times more powerful than the Saturn V, a true game-changer in aerospace engineering. While thrust is the headline, the design evolution of the Raptor engines deserves just as much attention. SpaceX's journey of refining the Raptor engine has been nothing short of remarkable. The original Raptor 1 design was complex and heavy, laden with numerous small sensitive parts. By the time Raptor 2 arrived, SpaceX had drastically simplified the engine, integrating many components and reducing its weight from 2,000 kilograms to 1,600. In 2024, the unveiling of Raptor 3 took the streamlining process even further. The new design reduced the number of small systems to a bare minimum, integrating them into larger, more efficient assemblies. The result was a lighter engine, now weighing just 1,525 kilos. This simplification wasn't just about weight reduction. It also improved reliability by eliminating many potential failure points. Raptor 3 also introduced several groundbreaking changes. For instance, it removed heat shields altogether, a move made possible by advancements in system reliability. This not only shaved off additional mass, but also marked a significant leap in engine durability. Secondary cooling systems were added to better manage temperature and pressure, further enhancing performance under extreme conditions. With such strides made in Raptor 3, it's fascinating to imagine what Raptor 4 might bring. While its full design hasn't been revealed, it's reasonable to speculate that it will take SpaceX's philosophy of simplicity and integration to its logical extreme. Raptor 4 could become a unified, seamless engine, free of the small parts that once posed risks. One key innovation likely to play a role in Raptor 4 is the use of welding techniques to replace traditional flanges and screws. These components, while functional, often absorb and retain heat, increasing the likelihood of overheating and leaks. They also add unnecessary weight to the engine. By switching to welded joints, SpaceX could dramatically reduce mass, improve reliability, and minimize potential failure points. But of course, welding has its drawbacks, particularly when it comes to maintenance and repairs. Unlike flanges and screws, which allow for easy disassembly, welded components would require the engine to be cut apart for servicing. However, the trade-off is worthwhile if it results in lighter, more reliable engines that are better suited to the extreme demands of spaceflight. This shift towards simplicity and integration also has implications for production speed. Currently, Raptor 2 engines are produced at a rate of 1 per day, a remarkable achievement in its own right. With the improvements introduced in Raptor 3, this pace is expected to accelerate. By the time Raptor 4 enters mass production, we could see SpaceX manufacturing multiple engines per day, paving the way for large-scale Starship operations. So, what do you think of Raptor 4? Could it be the engine that finally takes Starship to unprecedented heights? And what other upgrades might SpaceX introduce to push the envelope even further? Share your thoughts in the comments section down below, and don't forget to like and subscribe to stay updated on SpaceX's incredible journey. With each innovation, they're not just building rockets, they're redefining the future of space exploration. Now, this leads to my next question: when will Raptor 4 make its debut? Indeed, that is the burning question following the excitement around its potential. For now, we know that Raptor 3 is set to power Starship V2 starting in 2025. And with an anticipated increase in launch frequency that year, Raptor 3's performance will likely be proven quickly, clearing the path for its successor, Raptor 4. Looking to the past for clues, SpaceX transitioned to Raptor 2 in 2021, though it didn't become fully operational until later. Based on this timeline, Raptor 2's operational lifecycle spans roughly 2 to 3 years. If this trend continues, it's likely that Raptor 4 will not appear before 2025. Another key indicator for Raptor 4's timeline is SpaceX's Florida expansion plan. This ambitious strategy includes 44 launches annually, utilizing a 150-meter-high Starship version, likely Starship V3, and with an estimated thrust of over 10,000 tons or 103 meganewtons, it's reasonable to assume this version will be powered by Raptor 4. However, achieving such milestones hinges on SpaceX's ability to meet their targeted launch cadence. To launch Starship weekly from Florida, significant progress in operational efficiency is required. If the 2025 goal of 25 Starship launches is achieved, this equates to approximately 2 launches per month, or 1 every 2 weeks. While impressive, this is only halfway to the weekly cadence needed. Realistically speaking, SpaceX could double its launch frequency by 2026, reaching 1 launch per week. This timeline aligns well with Raptor 4's expected debut, giving SpaceX ample time to refine Starship's operations in preparation for major missions like Artemis 3, which is scheduled for sometime in the middle of 2027. If this trajectory holds, 2026 may be the year Raptor 4 ignites its engines, pushing SpaceX further toward revolutionizing space travel. Though it may seem like a long wait until Raptor 4's debut, its steady evolution is undoubtedly causing ripples of concern among competitors, especially those developing methane-powered engines. With Raptor, SpaceX has not only set new benchmarks, but also ignited a fierce race in the realm of space exploration. Methane is increasingly seen as an ideal fuel for modern rocketry, prompting many competitors to adopt it. However, matching SpaceX's advancements remains an elusive goal. Take, for instance, Blue Origin's BE-4 engine. The BE-4 boasts a thrust of 250 tons, a figure that once allowed Blue Origin to claim superiority over Raptor, specifically Raptor 2. Yet this confidence was shattered with the unveiling of Raptor 3, which surpassed BE-4's thrust capabilities. The gap is set to widen even further with the introduction of Raptor 4, leaving BE-4 struggling to keep pace. Beyond thrust, the BE-4 faces significant challenges in its development and deployment. Its sluggish production timeline has caused repeated delays for vehicles like Vulcan, and it has yet to power Blue Origin's new Glenn into orbit. Furthermore, the BE-4's complex design makes it far less adaptable to upgrades compared to the streamlined and ever-improving Raptor. This rigidity diminishes its potential for future versions, leaving it trailing behind. Globally, competition with Raptor also emerges from China, where companies are fervently emulating SpaceX's technology. While many attempts have fallen short, a few have achieved some success, most notably Landspace's Ch.2426 rocket. However, the advent of Raptor 4 with its unmatched performance and scalability will likely eclipse these efforts. With each iteration, Raptor edges closer to cementing its place as the undisputed leader of space rocket engines, solidifying SpaceX's dominance in the industry. In order to bring the Raptor 4 into reality and fully realize its potential, SpaceX must first conquer several significant challenges. These challenges will be put to the test in upcoming Starship flights, where the engines play a critical role not just in propulsion, but also in navigation and deceleration during landing. Together with the flaps, the engines must demonstrate precision and reliability to guide Starship safely back to Earth. SpaceX's ultimate ambition remains the successful use of the Mechazilla arms for landing. This was accomplished with Super Heavy during Flight 5 and will likely be repeated in Flight 7 and beyond. However, the greater hurdle lies with the ship. This upper stage endures an intense, prolonged journey through space before attempting a controlled landing using the chopstick system. The engines will be essential to this effort, enabling SpaceX to achieve its groundbreaking goal of full reusability. Beyond landing, SpaceX must refine the intricate process of engine activation and shutdown. Recent flights have demonstrated progress with smoother transitions between flight phases, yet Starship's aspirations extend beyond Earth, particularly in developing a reliable orbital refueling system. This ambitious undertaking will demand further engine upgrades to ensure efficient and consistent performance under extreme conditions. Overcoming these challenges is essential for SpaceX to pioneer a new era in reusable spaceflight and solidify the Raptor engine as a cornerstone of its success. The Raptor engine drives SpaceX and Starship toward earth-shattering milestones in space exploration. With limitless potential, who knows if a Raptor 5 or 6 might follow? For now, all eyes are on Raptor 4, the most anticipated version yet. Are you ready for its arrival? And with that, thank you so much for tuning in. As always, this has been Kevin from Great SpaceX. Until next time, keep looking up.